Alright, this is Sparks Pre-Calculus. This is day 19. We're going to be solving polynomial equations and inequalities. So you can see the graph of f of x down here to the right and down. We're going to factor f of x and use those factors to find the zeros of the function. So if you want to challenge yourself to factoring it on your own, pause it now. Otherwise, I'm going to give you the answers right now. Alright, so looking at f of x, we have x cubed plus x squared minus 6x. There's an x in every one of those, so we can factor that out. And we can continue to factor what's inside the parentheses. You could use a box and diamond if you'd like. This is going to be x and x, two numbers that multiply to -6 and add to 1. That's going to need to be -2 and +3. So there is our function in factored form. And what you can notice is that this gives us our zeros. If we set this equal to 0, we would get that x is equal to 0, x is equal to 2, and x is equal to -3. And you can see here's -3, here's 0, and here is 2. Those are our zeros. So now we need to find the places where f of x is equal to 0, where it's greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0. Go ahead and challenge yourself. Pause this video right now, and then I will give you the answers. Alright, as you can see, I had already given you those because we could tell because of how we factored it, also from the graph. The places where it's greater than 0 are not including -3, all the way to not including 0, and then also from +2 to positive infinity. And then everywhere else is less than 0, -infinity to -3, and 0 to 2. And then notice how number 4 and number 5 are different than 2 and 3 because we are greater than or equal to 0. So it includes those 3 points where it's actually equal to 0. Now we're given a different function, g of x, and again, we're going to factor to find the zeros of the function. If you'd like to challenge yourself to see if you can do it, factoring by grouping looks like the way to go. You can pause this right now, otherwise I'm going to work it out. Alright, so g of x is equal to x cubed plus 3x squared minus 2x minus 6. There's nothing common about those. Since there's 4 terms, I'm going to look and see if I can factor by grouping. So I'm going to take these 2 terms and find out what's common. Looks like it's an x squared. Excuse me. Leaving me with an x plus 3. I'm going to go ahead and factor that negative out here. And I want to find out what's common about 2x and plus 6. Looks like there's a 2. So I've got x squared, x plus 3, minus 2, and then I have x plus 3, and you can see my common factor. So this is x squared, let's start that over, x plus 3, that's the common factor, and then that's times x squared minus 2. Now notice this looks like the difference of squares, but it is not. It does not factor as a difference of squares because 2 is not a perfect square. But we can factor it without a perfect square, because we do know what the square root of 2 is. So we'd have x plus root 2, not a very nice number, x minus root 2. So that does help us find our zeros, because we can factor it, but it's not a nice number. So we can find our zeros. That's going to be x is equal to -3, x is equal to negative root 2, and x is equal to positive root 2. Which we can put for g of x equals 0. X equals -3, negative root 2, positive root 2. And root 2 is approximately equal to 1.414. And you can see those zeros right here. There's our -3, there's our negative root 2, and here's our positive root 2. Go ahead and fill out the rest of this chart. Pause it, and I will give you the answers. And here we go. Where it's greater than, where it's less than, where it's greater than or equal to, and where it's less than or equal to 0. Again, notice where they have brackets and where we don't. On the next page, we're going to develop an algebraic analysis method that will let us solve polynomial inequalities. You probably remember doing this with lines. and or single variable inequalities. So first thing we're going to do is completely factored. It's not factored, but we can factor something out of that, which will give us, excuse me, x squared plus x minus 6, which is also equal to x times x. This looks familiar. And we know that is greater than or equal to 0. Second, we're going to set each factor equal to 0 to find the zeros of the function. So we have x equals 0, x equals -3, and x equals +2. I probably could have put those in a slightly different order. It would have made more sense. Let's call this 0. There's -3, and there's +2. So, depending on how you learn how to do inequalities, this step may or may not be familiar. We're going to pick a number in between each one of these intervals, similar to when we did absolute value earlier. So I'm going to pick -4. We could pick -1, and between 0 and 2 we could pick 1. So instead of plugging them all into the original, I'm going to plug them into here, where we already have it factored. So if I plug -4, x is going to be negative. And in the middle, if I plug in -4, I get -4 plus 3, which is also negative. And then if I plug in -4 into x minus 2, I get out negative. Negative times a negative, and a negative is a negative. So here, less than -3, we have negative. And we do the same thing right here, where we're going to plug in -1. Well, the first one's negative, because we get negative, x is equal to -1 is negative. Then we plug it into x plus 3. We get -x plus 3, or sorry, -1 plus 3, and that's going to be positive. And then when we plug in 1 into the other one, we get 1 minus 2, which is negative. Negative times a positive is negative times another negative, and this ends up being positive. So in here, go away. In here, it's positive. And then we go ahead and pick 1. Well, 1 is positive. 1 plus 3, that's positive. And 1 minus 2, that's negative. So we're going to have negative in here. And then over here, I forgot to pick something. Let's pick 3. Well, 3 is positive. 3 plus 3 is positive. And 3 minus 2 is positive. So this is positive. As we're talking about the function f of x, we're talking about the y values. This is where the y values are negative, positive, negative, and positive. We're going to use that to sketch a graph of this function here in just a sec. Since the original problem that we wanted was, we wanted f of x to be greater than or equal to 0. Greater than or equal to 0. So we want to look at all the places where f of x is positive or equal to 0. And that happens on these intervals right here, and equal to 0, so we're going to include the endpoints. So we have that being -3 to 0 inclusive, because we're equal to 0, and then from 2 to positive infinity. And we can take a look right here. Our sign analysis is confirmed by the graph, because y values were less than 0 from negative infinity to -3, and then above the x-axis, the solution to our graphs. I guess I didn't really want that. We're just talking about the solution from -3 to 0, and then from 2 to 0. So we can do it by the picture. If we don't have the picture, we don't know how to graph it, or don't want to graph it, we can also use this sign analysis to figure out where it is above the x-axis. Alright, this time around, why don't you go ahead and get started. We're going to do one step by step. So please do step 1. You want to completely factor it. I think that we've already done this problem, so it should be fairly easy. And we'll pause it after, before each step. So pause this now and do step 1. And what we have then is x plus 3 times x squared minus 2, because the x squared minus 2 really doesn't factor. Although if we were to solve it, we know that's root 2 and root 2. So we set each factor equal to 0, and do that and divide your number line. So pause it now and do step 2 all by yourself. Alright, so for step 2, we end up with -3 and plus or minus root 2. And when you put it on a number line, it looks something like that. So for step 3, you need to pick a number in each one of those intervals. Recall that this is approximately equal to -1.414 and positive 1.414, and then you're going to determine if the whole entire polynomial is positive or negative. So pause this now and then check your answers. Notice that when we're picking these numbers, we're not worrying really what the value of the function is. The only thing we want to know if it's positive or negative. You can shorten up some of your arithmetic. I ended up with negative, positive, negative, positive. So to solve this problem, we're going to refer back to the original problem, and we want this to be less than 0. So we want all the places where the function is the function is less than 0, or where it's going to be negative. So we want less than 0 means graph is below x-axis. This is where f of x is negative. So we end up with the intervals negative infinity to negative 3, and from negative root 2 to positive root 2. And then we can compare that to our graph right here. We're looking for places where it's less than 0. And you can see that on the graph. That happens between negative root 2 and positive root 2. These are open circles because it is not equal to 0. All right. I'm going to let you do this one on your own, so you can check your answer here in a minute. Notice this one is already factored. Notice that this is negative already, and notice that, go away, notice that this has a square. See if that trips you up anywhere. Anyway, I'm going to give you the answer, so pause this right now. All right, so this is what I got. I got negative 2, 0, and 2 as my zeros, and when I plugged numbers in those intervals in, I end up with negative, positive, negative, negative. Two things that I was worried about. One, because this first one is negative x. That's why I pointed out at the beginning. So when we plug in a negative number, we get positive. Plug in a negative number, it's positive. You plug in a positive number. So that was one place I was worried that you would get tripped up. If it was, pause it and fix it right now before you take a look at the rest of this. The second thing that we're going to notice when we took this graph is this negative thing and what is going on. So we're looking for h of x is less than or equal to 0, so where it's below or at the x-axis, and that happens between negative infinity and 2, and then also from 0 to infinity, because even though it comes back to the back up to the x-axis at 2, it turns around and goes back down. So if we take a look at the graph, you can see what happened here. You can see when we're looking for the function is less than 0. Well, that one's pretty obvious, and it could be equal to, so we can close that dot. But then we have this case where it comes back through the x-axis, goes down, turns around, comes back up, and then touches and then turns itself around. So you can see from the picture why it was that it was negative on both sides of the 2, as it doesn't actually go through. It just comes up and becomes tangent to the x-axis and then turns right back around. So this is a good question here. How would the solution to your inequality that we just did be different if the original inequality had a 2 in front of it? I'm going to let you think about that and explain this, and then if you need to, we can talk about it in class. On the next page, we have a problem that's slightly different. This time, we have x cubed minus 9x is greater than or equal to 3. And it asks, what do you notice about this polynomial as opposed to the previous examples? Well, let's go back and look. The previous examples, we had it less than or equal to 0. And in this example, we had it less than 0. So if we consider this one right here, what I notice is that this is not equal to 0. We're not comparing the function, seeing if it's above or below the x-axis. We're trying to see if it's above or below the line y equals 3. This function is not being compared to 0. And one other thing about this function is the other functions we did were factorable. Even if we were to solve this for 0, which is what we're going to do in this step right here, x cubed minus 9x is greater than or equal to 3. We can subtract the 3, and we get x cubed minus 9x minus 3 is greater than or equal to 0. This right here is not factorable. And here's a little statement about that right now. So how else can we do it? We can put this in the graphing calculator. So if you have a graphing calculator, you can go ahead and sketch it. I think most of us downloaded something onto our phones, so we would have one. You can get out Desmos or another graphing calculator and go ahead and sketch a graph. It looks something like that, and it's not very pretty. And you can kind of zoom in on each one of those, or the calculator has a feature that allows you to find the zeros. It seems to me when on the Desmos Isaiah showed me, you can just click and it tells you exactly where they are. If you're using a TI 83 or 84, you would hit from the graph screen, you would hit second trace, and you'll see there is a calc is above it. So second trace is a calculate feature, and then you'll see, I don't know what number it is, you'll see zeros. I can't remember, does it have an E in it? Nope, no E. You'll see where it says the zeros of the function. And then you're going to have to find, you have to give it some bounds so it'll make a guess. You have to go tell it, you know, you want to go to the left and right of where it crosses because there used to be a sign change. And then you do the same thing over here and do the same thing over here. Or you can zoom in. Having the calculator calculate it, though, is you'll get more accuracy. Sometimes you have to zoom in quite a bit before you can get the pixels in a way that you can get pretty accurate. Anyway, by doing that, you should get somewhere around x equaling negative 2.817, x is equal to negative 0.338, and the third one, x is equal to 3.155, or somewhere close to that. So, graphically, what does the solution to this inequality represent? Inequality, we want the function to be greater than or equal to 0, and what would that solution be? So when the x cubed minus 9x minus 3 is greater than or equal to 0, that is when, oh look, I'm still in red. Graph is above or at the x-axis, and that occurs between negative infinity and negative 2.817. Are we equal to? We are equal to. That should be that way. And it also happens when we are bigger than or equal to 3.155 all the way to infinity. Somebody watching this in my future years is going to wonder who Isaiah is. Anyway, that is the end of this video, a whopping 17 minutes. Sorry guys. I will see you in class. Bye.